Hello, welcome to Chapter 8, homework questions 17 to 23. Question 17. Use the process you developed in problems 8 through 14 to factor the following quadratics if possible. All right, let's go ahead and start with A. All right, so we want to set up our generic rectangle. We have x squared and minus 12. Now remember, you can put your x squared in the bottom left as well. And we want to figure out by using what Casey found out in her problem is that the diagonals have to be the same in terms of their product. So we know that the product must be negative 12x squared. And then the sum we have to be able to get is negative 4x. So what factors of negative 12 are going to add to give you negative 4? So if you need to, you can write your factors off to the side here and figure out which ones are going to give you 4. Now remember, it does have to be a negative 12, so one of your numbers has to be negative. So it looks like 6 and 2 are our answers. Now which one is going to be negative to get us a negative 4x? That would have to be the negative 6. So that adds to give us negative 4, but multiplies to give us negative 12. Let's put the x's in there as well. So we have negative 6x and 2x. So now we can go ahead. We know this is going to be x times x. This will be 2. 2 times x is 2x, and negative 6 times x is negative 6x. So we have our factors. We can rewrite them as x plus 2 times x minus 6. And so that's how we answered question 8-14, and we'll continue to use that process as well. So let's go ahead and look at B. Once again, set up our problem. We have 4x squared this time, and a plus 1. So the product of 4x squared times 1 is 4x squared. And on this one, we need to add to get 4x. So what things multiply to give us 4 that are going to add to give us 4? And you can see the 2 and 2 work. So 2x times 2x is 4x squared, and 2x plus 2x is 4x. So we'll put our 2x's in our generic rectangle, and we'll go ahead and find the links. 2x times 2x gives us a 4x squared. This would be a plus 1. And this would be a plus 1 as well. And you can see that that works out. So our answer in terms of the product is 2x plus 1. And you can put squared because it is the same, or you can just rewrite it and say 2x plus 1 times 2x plus 1. And there you go. All right, let's move on to C. 2x squared and minus 5. And as we set up our diamond, the product is negative 10x squared, because remember, this product has to be equal to this product, going back to Casey's pattern. And then the middle term is negative 9x. So factors of 10, negative 10, so 1 and 10, 2 and 5, one of those has to be a negative. Which one of those would give us a 9? The 10 and the 1 would give us a 9. Which one's going to be negative? The 10, because we want to add to get negative 9. So we'll put negative 10x, and so there's an x and an x and a 1x. And so to complete the rectangle, we're going to have a 2x times an x, because we need the 2 on top so that we can get 2x times minus 5 to get negative 10x, and then x times plus 1 to get x. So this is going to be equal to 2x plus 1 times x minus 5. And you can have the order of the x minus 5 first and the 2x plus 1 second. And our last one, D. So 3x squared and minus 8 is the ones, and then the x's need to be split up to get 10x. So our diamond, negative 8 times 3x squared is negative 24x squared. So we know it needs to multiply to give us that, but then it has to add to give us that 10x. So factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. To get negative 24, we do need one of them to be negative. So do any of those give us a value of 10? Now, the negative 4 and the 6 might look like it's going to give you 10, but remember, one of them has to be negative. So if you added those numbers, you're going to get 2 or negative 2. So it looks like it'll be negative 2 times 12. So 12 and negative 2, shouldn't have said negative 2 just yet, but 12 and 2, which one's going to be negative? And it will be the 2 because 12 minus 2 is 10, and we have our x's as well. So we'll put the 12x and the minus 2. It doesn't matter which one you place them in. And then we can figure out from there, we need a 3x here and an x here. And then 3x times 4 gives us 12x, and x times negative 2 gives us negative 2x. And you can also check the ones column. Negative 2 times 4 is negative 8. So this will factor to x plus 4 and 3x minus 2. And so there's 4 questions using the process we used in class for problem 8-14, along with 15 and 16. Question 18. For each rule represented below, state the x and y intercepts if possible. So on part A, we need to label which one's the x and the y intercept. So x-intercept, we actually have 2 of them. This one right here, looks like we're going up by 1s on these. So that would be at negative 1, 0. And then the other one looks to be at 3, 0. And the y-intercept is where it crosses the y-axis when x is 0. And that appears to be at 0, negative 3. We want to write those as ordered pairs. The intercepts are points on the graph. So I think that answers the question there. On B, we have this one right here. It appears to be at 2. Looks like it's going up by 1s again. So 2, 0. Doesn't appear to have a y-intercept, so it looks like we just have an x-intercept on B. On part C, so when we have the x-intercepts, we're looking for x values when y is 0. So let's look for when y is 0. Looks like we have one here, here, and here. So we have 3 of them. Negative 3, 0. Negative 1, 0. And 1, 0. And then do we have any y-intercepts? And the y-intercept is when x is 0. So look for when x is 0. And it looks like we have 1 at 0, 2. And for D, D is a linear equation, so we want to write this in slope-intercept form to find the y-intercept. Or, if you want, another way to look at this, the x-intercept is when y is 0, and the y-intercept is when x is 0. So you could plug 0 in for your x value, 5 times 0 minus 2y equals 40, and get negative 2y equals 40 and divide by negative 2 to get negative 20. So we know the y-intercept is 0, negative 20. And then to find the x, we'll plug 0 in for y and solve and get 5x equals 40, divide by 5, x is equal to 8. So the x-intercept would be at 8, 0. So that's another way that you can look at finding the intercepts given a linear equation. And I added no y-intercept to B. Question 19. Write the equation for the following 2 sequences in first term form. Go ahead and set this up in table form. Just kind of helps see things a little bit better. So term 1 is 1/2, term 2 is 1/4, and term 3 is 1/8. So what is happening from one term to the next? It's being multiplied by a half each time. And so therefore the first term is a half and our multiplier is a half. So when we go to set up our form, t of n is equal to the first term, which is 1/2, times the multiplier, which is 1/2, and then n minus 1. And once again, remember the first term form, we're using the first term of the sequence, which in this case is 1/2. That's why we're using the n minus 1. On B, once again, I'm going to set up a table. And you don't have to set up a table, but as I said, I think it's just a little bit more visual. Term 1 is negative 7.5. Term 2, negative 9.5. Term 3, negative 11.5. So you can see that on this one we are subtracting or adding a negative 2. to that. And so first term form, t of n is equal to the first term, which is negative 7.5. And then you are adding a negative 2. So minus 2 times, instead of n, it will be n minus 1. If you wanted to write that first, you're more than welcome to. So it could look like negative 2 times n minus 1, and then minus 7.5. And once again, you can, if you're kind of not sure if this works, plug in term 1. What do you get? Negative 2 times 1 minus 1, minus 7.5. This would be negative 2 times 0, minus 7.5, which would just be negative 7.5. And we should try it for term 2 and 3 just to verify, but that is correct. Question 20. The value of bullseye stock has decreased 8% each year for the past several years. In 2010, the stock was worth $50, and that pattern continues. How much will it be worth in 2015? So we have an 8% decrease. We have an initial value of 50. So our initial value starts at $50. And we have 100% start, but it decreases 8%. So that would be 92%, or as a decimal, 0.92. So we have our multiplier, we have our initial value of 50, and it wants to know what will happen in 2015. So you could set up a table and just kind of work through, since 2015 is not that far from 2010. N would be 0, though. That represents the initial year of 50, and this would be 2010. And then 1 would be 2011, 2 would be 2012, 2013, 14, and 15. So you could just work through the table and multiply by 0.92 until you get down to year 5. Or you can write your equation, t of n equals the initial of 50, the multiplier 0.92 raised to the n power. And then since you're looking for year 5 years in, you would plug in 5 into the equation, and you would get a value of 32.95. And it is 954, but we'll round because we are talking about money to $32.95. So in 2015, the bullseye stock is predicted, because if the pattern continues, so I don't want to say will, I'll say is predicted to be $32.95. Question 21, find the point of intersection of each system. When we're looking for the point of intersection, we're solving the system, so we can solve using substitution, elimination, or we could potentially graph these. Part A looks like it is set up for substitution, so you don't have to use substitution, but because it's set up that way, that's the way I'm going to go ahead and solve this one. I'm going to substitute 2x minus 3 in for y into the second equation. And then we're going to solve this equation for x. Add 3, which would be 18, divide by 3, x is equal to 6. And now we can plug 6 back into y equals 2x minus 3. And that would be 2 times 6 minus 3, or 12 minus 3 is 9. So we're looking for the intersection. So the intersection would be at 6, 9. That would be the ordered pair that would satisfy the system. On B, we have 3x equals y minus 2. And we have 6x equals 4 minus 2y. We could, once again, use substitution. Since I did that for part A, I'm going to go ahead and use elimination for part B so you can see the two different methods. If I'm going to do that, though, I want to write these in what's called standard form. I want the x's and y's on the same side so I can use my elimination. So I'm going to subtract y on the first equation, so 3x minus y is equal to negative 2. And then on the second equation, I'm going to add 2y. So that'll give me 6x plus 2y equals 4. Now I have it set up so I can multiply if I need to get the coefficients the same for a certain variable. I'm going to go ahead and multiply the top equation by 2 since I have a negative 1 and a positive 2 there. So make sure you distribute the 2 all the way through. So that's 6x minus 2y equals negative 4. And then the second equation I can just leave the same because now my y values are opposite. And so when I go to add, I get 12x, those cancel, equals 0. Divide by 12, and x is equal to 0. And 0 is a number, so we're good to go. It's not undefined or anything. And then you can plug 0 back in. I'm going to plug it back into my first equation. 3 times 0 is equal to y minus 2. That's 0 equals y minus 2, so then I can add 2 to the other side and get y is equal to 2. Once again, looking for the intersection, so that's the point 0, comma 2. Remember, if you do want to check these, you can plug them back into the original, and they should satisfy both equations. Question number 22. Solve each equation below for the given variable if possible. So on part A, we have a proportion 4x divided by 5 is equal to x minus 2 times 7. I could do this in 2 steps to get rid of the denominator, multiply by 5 and then multiply by 7. I'm going to go ahead and multiply by both of them, and by doing that, if I multiply by a 5 and a 7, that's 35. So I'm going to multiply by 35. So this will be 4x over 5 times 35 over 1 is equal to x minus 2 over 7 times 35 over 1. So the 5 cancels with the 35 to give you 7 times 4x, and that's 28x. And then the 7 and the 35 cancel on the other side to give you 5, and that'll be 5 times the quantity of x minus 2. So then you can distribute that part, subtract the 5x. That'll give us 23x is equal to negative 10. And then when we divide by 23, x is equal to negative 10 over 23. And we can leave the answer just like that. So that solves part A. Part B, we have negative 3 times 2b minus 7 is equal to negative 3b plus 21 minus 3b. So we can use the distributive property. Make sure when you distribute the second time it's a negative times a negative, so it's a positive 21. And then you can combine like terms on the other side. So negative 3 times, or negative 3b minus 3b is negative 6b plus 21. Get our variables on the same side by adding 6b. You'll notice that actually both of them cancel out, and you're left with 21 equals 21. So what value of b satisfies this equation? All real numbers. So b can equal any real number or all real numbers. All right, and for part C, 6 minus 2 times the quantity C minus 3 is equal to 12. So we do need to distribute. We can't take the 6 minus 2. We have to do multiplication first. So that's 6 minus 2C plus 6 equals 12. And then negative 2 times negative 3. We can combine our like terms, and it looks like we'll get 12 minus 2c equals 12. Since we already have one variable by itself, we're going to go ahead and move the constant by subtracting 12. That'll be negative 2c equals, that's supposed to be subtraction, so that's 0 divided by negative 2. C is equal to 0. And so those are just 3 equations with one variable. Kind of set up different ways, though. Question 23. Find the equation of the line that passes through the points. So we're looking for, make sure you're reading, equation of a line. So given 2 points, we can either set up the table and do it, or we can use our change of y over change of x. And so that will be 200 minus 300. That's my change of y. Change of x is negative 800 minus negative 400, so it looks like I'll get negative 100 over, remember this will be plus 400, so that's negative 400. Reduce that to 1/4 or 0.25. To find the y value, we can plug in the information we know. I'm going to use the point negative 400, 300, and plug in the information with my slope of 1/4. So it would be 300 equals 1/4 times negative 400 plus b, which we don't know what that is yet. So that'll give me negative 100 plus b, add 100 to the other side, and we get 400 is equal to b. So we have the things that we need. We can now write the equation. Y is equal to 1/4 x plus 400. And that's what it wants. It wants the equation of the line that passes through the 2 points.